Last month, neuroscientists at Stanford published something that should terrify every parent. They scanned the brains of 7-year-olds, some who used TikTok daily, some who didn't. The difference, shocking. And if you have a child or plan to have one, what you're about to see will change how you think about screens forever.
Today, we're diving into something most parents don't know is happening. What is TikTok's algorithm actually doing to a developing brain? Not just behaviorally, but physically, at the neurological level. And the science? It's already here.
Let's start with what's happening inside a 7-year-old's brain. At this age, the brain is in what neuroscientists call a critical period. This is when synaptic connections, the pathways between brain cells, are forming at an incredible rate. We're talking about 700 new neural connections every single second. The prefrontal cortex, the part responsible for focus, decision-making, and impulse control, it's not fully developed until age 25. But at age 7, it's incredibly vulnerable. Now here's where TikTok comes in. Every time a child swipes to a new video, their brain releases a hit of dopamine. Dopamine is the neurotransmitter of reward and motivation. It tells your brain, this is good, do this again. But here's the problem. TikTok's algorithm is designed to optimize for engagement. It learns what keeps each child watching and serves them exactly that, over and over in 15-second bursts. This creates what researchers call dopamine dysregulation. In a study from UCLA, researchers found that children exposed to short-form video content showed dopamine spikes 3 times higher than those reading books or playing outside. 3 times. And this is where the brain scans get disturbing.
A 2024 study published in the Journal of Developmental Neuroscience followed 200 children aged 6 to 9. Half used TikTok for at least 1 hour daily. The other half had minimal screen exposure. After 6 months, researchers performed fMRI scans. The results were undeniable. Children in the TikTok group showed, number 1, reduced gray matter in the prefrontal cortex. This is the area responsible for attention and impulse control. Number 2, hyperactivity in the nucleus accumbens, the brain's reward center. This means they were craving more stimulation constantly. Number 3, disrupted connectivity in the default mode network. This is the network that activates during rest and creativity. In simple terms, their brains were being rewired to crave instant gratification, struggle with sustained attention, and have difficulty in creative, free-thinking states. But it gets worse. The study also measured something called synaptic pruning. During childhood, the brain naturally prunes away unused neural connections to make the brain more efficient. It's like trimming a tree, cutting away weak branches so strong ones can grow. But when a child is on TikTok for hours daily, the brain prunes connections for sustained focus and deep thinking because they're not being used. Instead, it strengthens pathways for rapid content switching and novelty seeking.
So what does this mean in the real world? Teachers are already reporting massive changes. A 2025 survey of 5,000 elementary school teachers found that 73% reported students have shorter attention spans than 5 years ago. Children struggle to focus on single tasks for more than 3 to 5 minutes. They show signs of anxiety when devices are removed, and their ability to engage in imaginative play significantly reduced. Dr. Sarah Chen, a child psychologist at Harvard, put it this way: "We're seeing 7-year-olds with the reward-seeking behavior patterns we used to only see in gambling addicts. Their brains are being trained to need constant stimulation. And here's what keeps me up at night. These changes are happening during critical developmental windows. Ages 6 to 12 are when executive function, emotional regulation, and social cognition are formed. If we're disrupting this process with algorithmic content, what kind of adults are we creating?" Now let's talk about the AI part of this equation. TikTok's algorithm isn't just showing random videos, it's predicting what will keep each individual child watching. It analyzes watch time, replays, shares, facial expressions captured by the front camera, even how fast they're scrolling. And then it builds a psychological profile. What makes this child laugh? What makes them anxious? What keeps them frozen on the app? The AI is essentially studying your child's brain in real time to figure out how to keep them hooked. And a 7-year-old brain? It has zero defense against this. Their prefrontal cortex, the part that says, maybe I should stop, isn't developed enough to fight the dopamine hits.
Okay, so if you're a parent watching this, you might be panicking right now. Take a breath. The good news? The brain is plastic. Neuroplasticity means the brain can rewire itself. The changes we're seeing aren't necessarily permanent, especially if we intervene early. Here's what the research suggests. Number 1, delay social media and short-form video apps as long as possible. Ideally, wait until at least age 12 or 13. Number 2, if your child already uses these apps, set strict time limits, no more than 30 minutes per day, and never right before bed. Number 3, encourage activities that build sustained attention, reading physical books, building with Legos, playing outdoors without devices. Number 4, model good behavior yourself. If you're constantly on your phone, your child will copy that. Number 5, have honest conversations with your kids about how these apps are designed. Even young children can understand that the app wants you to stay on it. The research is clear. The earlier you act, the better the outcomes.
Look, I'm not here to shame anyone. Parents are doing their best in a world that didn't exist when we were kids. But we do need to take this seriously. AI algorithms are literally reshaping our children's brains. This isn't hypothetical. This isn't fear-mongering. This is neuroscience. If you found this valuable, please share it with other parents. Hit subscribe for more breakdowns on how AI is changing our brains. Next week, we're covering why your brain thinks ChatGPT is your friend and the mirror neuron trick that's making it happen. In the meantime, go hug your kids and maybe put the phones down. I'll see you in the next one.